Welcome back to my YouTube channel. We are given this here. We're given example 3, a single plate clash with a contact. We know when you're dealing with a single, always when you're dealing with a single, you must know single plate number of contact will be 2. If you have been watching my videos, you'll understand what I'm saying there. So on both sides, uh, required to transfer 125 kilowatts. This is power at 20 rests per seconds. The outer diameter of the contact surface is 350 and the coefficient of friction is 0.4. The uniform pressure, okay, that means it's a new class. This one, it's new. Obviously we don't expect to have we expect it to operate well. Still new. The contact surface is this. Here's the pressure. Calculate the inner diameter of the friction surface. Assume that it's a uniform wire. You want the inner diameter of that. Okay, it's fine. So now here, what are we given here? We must check. What are we given? We want R, right? We must check what are we given. So and then this power is for two clash. Must be very careful for two clash, for two plates. Remember, they are like this. There is a plate, then there are discs here. Yeah, we have two discs like that when they're making contact. So there are two. So you must be very careful if they are like this. So what I will say, we have given power. If I can say power is 2 pi nt over 60. If I make t the subject, would be 60 p over 2 pi n, right? Then 60, then the power there, it's 125 times 10 to the power of 3 over 2 pi n, whereby DC was was the rest per watt seconds. Okay, sorry, was seconds. I do not use this formula. I thought it was minutes. Do not use this. Cancel out the 60 because the rest per seconds will be like this. So torque will simply equals to P over 2 pi, just like this. So we know this, it's 125 times 10 to the power of 3. Remember, it's in kilowatts, over 2 pi, which is it was 20 reds. So this torque will simply 994.72 Newton meter. And then guess what? This is for two surfaces. Remember, for two surfaces was generated. Remember, two surfaces. I said we are dealing with a single class, two surfaces, and then two surfaces on both sides required to transmit. But is let here in English it says I'm taking why I'm saying this is for two is because it's the English that says so. A single plate with the contact surfaces on both sides is required. On both side is required. The teller is required to transmit. On both sides is required to transmit that. So it's for two surfaces. What about one? Let's see now about one. What about one surface? If I want torque for one, divide that thing by 2. You can say 994.72 divided by 2. I will have 497,36 36 Newton meter, then for each surface, because now we can find R, because R is 1. We don't want 2 diameters, 2 R's. If you use this one, then you can use this one and be fine, but you will be required that your final answer will divide by 2. So but anyway, let's just stick with this torque. If we have a torque, we know that torque, the original formula for torque is this multiplied by F axial. You can say F axial multiplied by Rm multiplied by the, what is this, the number of contact, if you know the number of contact. But be aware, this is the torque for each. Now is not for each. Be aware, one plate like this will have one contact. Here it's a plate, it's one plate, and then the disc, number of friction plate will have one thing. You see, this is a plate, it's a plate, but now with single this thing friction disc here, you will have one contact. So you must be very careful. I know it's quite a trick, but not that much tricky. Then must be very careful then. Therefore, as we know, must be very careful. You must be very careful there. Right, be very careful. Okay, it's fine. Enough for the stories. Do we know F axial? Do we know this? We don't know those things. So let's start by F axial. Let's check. We're not given F axial, so how can we calculate F axial? We know that this is equals to pressure multiplied by area, right? Then pressure multiplied by pi r squared, like this. Remember, this is simply just the mean pressure. It is a simply mean pressure. It is not mean or maximum pressure. These two, they have their special formulas. They have their own formulas. This one is just for mean pressure, the one that you have given. But you have given a mean pressure, minimum pressure, maximum pressure. They have their special formulas. So yeah. So the pressure that we have given is need to be given the pressure, which is 170 kilopascal. So 170 times 10 to the power of 3 multiplied by pi. What is our R here? What will be the R? We don't know R. Remember, we don't know that R. All these R is unknown. So we simply have this as the axial force. So we have the axial force now. We've calculated. What about this one now? Since it's a uniform wear, remember they said it's a uniform wear, you'll have two. Remember, we have two theories. I've talked about this a lot on my previous video. Watch them. I've talked about the uniform wear and pressure theory. Simply, this is a pressure theory, right? They say, what is this? It's a pressure theory. Hopefully you remember this. Uniform pressure theory. So is 2 over 3 r cubed minus r cubed over r squared minus, not small r, big R squared here. We don't know nothing about this, simply this. So if we can grab the number of n will be equal to 1 now. Remember, if for each from here, for each surface, not surfaces, for each surface, now we'll have one number of contact. So here is the formula. I can simply grab this formula here and substitute our thing. We have the torque we've calculated for one. For each it was 497,36, right? Coefficient of friction, which is, it was what? That coefficient of friction, it was 0,4, which is the coefficient of friction multiplied by the axial force. It was 170 times 10 to the power of 3 multiplied by pi area as it is. We don't know r squared minus r squared multiplied by rm. We don't know nothing. We have 2 over 3 r cubed minus r cubed over r squared minus r squared multiplied by 1, which is the number of contact. So maths, now this and that will cancel. If you know your maths, this and this will cancel nicely. If they cancel, apply your maths. Here we have 497,36. Here we have 0,4 times 170 times 10 to the power of 3 multiplied by pi. Then I just want to use, let me just put the coefficient aside, multiply by, okay, 1 has no effect, so this will be multiplied by r cubed minus r cubed. It's just the maths now. So since it is a maths, I hopefully you know your maths. This is a fraction, right? But here we don't have fraction. Multiply by these 3 there. If you can multiply by that 3 there, use math, you'll have 497,6,36 multiplied by 3 is equal to 0,41 multiplied by 170 times 10 to the power of 3 multiplied by pi multiplied by, so we have this there. So now divide, remember this like this, remember divide by 0,4 times 170. Four 97,36 times 3 divided by 0,4 times 170 times 10 to the power of 3 times pi. This will be what? We've multiplied like this. I don't know the maths that you will use there, but that is what the maths that I will have me. I don't know which maths are you going to use, but if you use your maths properly, we are given anything like ratios, It's any diameter. Oh, we're given one diameter, and here there's one diameter that we are given. As you can check, yes, but we'll no problem. If we punch this, you'll have that this is 0,006. Not the final answer. I will write it like this. Since it's not the final answer, this will be r cubed. So we have r. This we have it because we've given an outer radius, or what, I don't, we've given outer diameter, so we can find the outer radius. So remember, r is simply diameter over 2. We've given the 0,36 divided by 2, which will simply equals to 0,175. So yeah, so here we have 0,006894 into 0,175 cubed. Mathematically, I will have 0,006984. I take this, will simply equals to minus 0,175 cubed is equal to, so if I have 0,006984 minus 0,175 cubed, I'll simply have 0,00162, let me say 5, since it's not the final answer. That is not the final answer. But now we have a negative here. Let me check. Where did I do seems like I did a mistake. I cannot have a negative value. Let me check here. Did I punch this row accurate? Yeah, the value here, I think when I punched, supposed to punch this accuracy, this side supposed to have something like 0, if I punch 0,03493, right? 0,003493. So yeah, then this will be 0,03493. It's equal to 0,00536. From this, if you punch this on your calculator, minus r cubed, then yeah, then if let's check now, if I can say, let me make this positive, we'll take this to the other side, then I'll have 0,00536 minus 0,003495. Then I take the cubed root both sides, then cube root will cancel with the root, will have this, what is inside cube root of this 0,00536 minus 0,0003495 495 or 493. Yes, 493 because here it is 3. 493. I simply got 0,123. Yeah, yes, it's in millimeter, right? R must be in meter. Therefore, if you want this to become in millimeters, you multiply this by 1000. This will be 123 millimeter. But the question did not say they want R. They wanted the diameter. Then diameter is 2 multiplied by R. Obvious that it's in millimeter, must be 246 millimeter. So this is what we have there. So thank you guys for your time. Please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video.